All right, IM3 classes. Today we are talking about how to solve logarithmic equations. So let's get right into it. Starting off, going to solve the equation. Log base 7 of a is equal to 3. What we want to do to solve this equation, easiest thing to do is to rewrite the equation as an exponent in exponential form. So remember, the base of the log is the base of the exponent. And then the a and the 3 are going to switch spots. The 3 becomes a power, and it's equal to a. And so where this looks really confusing, if we just go from here, write it as an exponent, write it in exponential form. That is really simple to solve. 7 cubed, 7 to the third power is 343. Yes, I believe. Or am I off on that one? Now I need a calculator to check. 7 times, yeah, 343. Okay. 343 is equal to a. Simple. All right. So let's look at an example where there's more going on inside the log. We're going to do the same thing. I'm going to write it in exponential form. So the base of the log becomes the base of the exponent. 0 is the exponent. It's equal to 8 minus b. So again, that first step, when you just have the log, just write it in exponential form. Spelling exponential wrong. So 9 to the 0 power, anything in 0 power is 1, is equal to 8 minus b. So from here, I'm going to subtract 8 from both sides. 1 minus 8 is -7. Well, negative e, and then I'll divide both sides by -1. -7 divided by -1 is +7, is equal to positive p. Another example. Here, on this one, we can't write it in exponential form yet because we have this -4 on the side with the log. So we need to get rid of that. So to rewrite it in exponential form, you need it just the log on the one side. So what I'm going to do is start off, divide both sides by -4. And then over here, that's going to cancel these out. So I get log base 7 of 9n plus 2 is equal to -4 divided by -4 is +1. Now, if I write it in exponential form, it's going to be the base of log is going to be the base of the exponent. So it's 7 to the first power is equal to 9n plus 2. And now to solve this, 7 to the first power is just 7, is equal to 9n plus 2. I'm going to subtract 2 from both sides. So I get 5 is equal to 9n, and then divide both sides by 9. You can multiply that out and leave it as decimal. That'd be 0.555, or just 0.5 repeating, or just leave it as 5/9 is just 5/9 is fine. Either one. All right. One more example with everything. This one is written kind of poorly because it's not clear what the 4b is. So I'm actually going to add something, some parentheses here. So it's log base 12 of 4b. The -7s, you're not taking the log of that -7. So just like the last one, I can't write the log as an exponent until this stuff is gone. So I need to start off going to add 7 to both sides. So the -7 plus 7 cancels out. I get -2 times the log base 12 of 4b is equal to -11 plus 7 is -4. And then I need to get rid of the -2 on this side. So I'm going to divide both sides by -2. Times -2 divided by -2 cancels out. And I get log base 12 of 4v is equal to -4 divided by -2 is +2. And now this is where I can rewrite it as an exponential. So it's going to be the base of the log is the base of the exponent. So it's going to be 12 is the base. 2 becomes the power is equal to 4b. Now when I work this out, 12 squared is 144. Ooh. 144 is equal to 4b. And then divide both sides by 4. I get 36 is equal to b. All right. So again, just want to make it clear, from here to here, you write as an exponential. All right. Next example. So the next ones we're going to do is we're going to have multiple logs in one problem. So we need to, the goal again is to get this down to a single log so you can rewrite it in exponential form to make it easier to work out. So for this, I need to condense. So I'm going to use properties of logs first, this first step, to condense the logs down to 1. All right, so condense. So this side is still equal to 5. This side, log base 3 of 6 plus log base 3 of -4x. When you're multiplying here, you, when you add here, you multiply these two in a single log. So log base 3 of 6 times -4x. So condense, I'm going to go ahead and multiply that out. So it's going to be log base 3 of 6 times -4 is -24x is equal to 5. Now, once I'm here, I'm going to write as an exponential, convert to an exponential. So the base of the log is 3. So the base of the exponent is 3. The 5 becomes the power, and it's equal to -24x. All right. From there, now you just multiply that out. So 3 to the 5th power comes out to 2. I want that in black. 3 to the 5th power is 243 is equal to -24x. And then I'm going to divide both sides by -24. So 243 divided by -24, that comes out to 10 point, or it's -10.125. I should double check my math on that real quick. 243 divided by 24 is 10.125, -10.125. All right. Next example. So same type of problem. This time we are using division or subtraction. So before I can write as an exponential, I need to get down to just a single exponent. So I'm going to, the first step here is I'm going to condense those exponents down into a single, or excuse me, condense logs down into a single log. So when I'm subtracting here, I divide those two in one log. So it's going to be log base 7 of 2x divided by 2, and then is equal to 2. Lots of 2's in this problem. What's nice here is those 2's actually end up canceling each other out. So that fraction reduces. So it's just log base 7 of x is equal to 2. And then from here, I'm going to write as an exponential, convert it to exponential form. All right, so an exponential form, the base of the log becomes the base of the exponent. So the base is 7, the base of the exponent is 2. or excuse me, the base of the log is, or exponent is 7. The power is 2 is equal to x, and that's easy to solve. 7 squared is 49. Next example, another multiplication one. Condensed down into a single log, so that's going to be log base 3 of 4 times x plus 4 is equal to 2. I can now rewrite the log as an exponent. And so the base of the log becomes the base of the exponent. So it's going to be 3, power is 2, is equal to 4 times x plus 4. Here comes my daughter to check out the math. Come on up here, B. All right. So from here, I'm going to, you can multiply that out. 3 squared is 9. And then you distribute, so 4 times x is 4x. 4 times 4 is 16. Let me finish this and I'll get you a snack, okay?
Okay.
Okay. All right, subtract 16 from both sides. 9 minus 16 is -7. Equal to 4x. Divide both sides by 4. You can leave it as -7/4 or multiply or divide that out. You can use the calculator, that's fine. That comes out to -1.75. All right. Next one, last problem. I'm going to, again, condense it down to a single log. So log base 2 of 10 minus log base 2 of x minus 7. So that's going to be log base 2 of 10 divided by x minus 7 is equal to 3. Rewrite it as an exponential. So the base of the log is 2. So the base of the exponent is 2. The 3 becomes the power. And so it's going to be equal to 10 over x minus 7. 2 cubed is 8. And then from here, we want to get that x out of the bottom of the fraction. So the easiest thing to do from this point is just to multiply both sides by x minus 7. So the x minus 7 there and that x minus 7 cancel out. Distribute the 8 into here. So 8 times x is 8x. 8 times -7 is -56. Then I'm going to add 50. Okay, hold on. Going back. This is 10. I'm going to add 56 to both sides. So this cancels out. I get 8x is equal to 66. And the last step, divide both sides by 8. I'm going to be left with x is equal to, that should be divided by 8. I don't know why I wrote it 6. Divide both sides by 8. 66 divided by 8 is 8.25. And there we go. That'll do it for logs.